Alright, so I'm Zach.
I'm Zach.
And then that's Derek, who's filming us right now. So all three of us are currently juniors in the plastics engineering department. And one of the classes we're taking is heat transfer, so that's what this experiment is kind of briefly going to show an aspect of. So everyday water bottles, like Poland Springs and stuff, are made out of plastic, and the plastic material they're made out of is called polyethylene terephthalate, which is abbreviated to PETE. And it's a semi-crystalline material, so that means it has a melting point, which is important for this experiment. And the DSC is an experiment you can run on different plastics materials to find like a glass transition temperature or a melting point, which is what's important for this experiment. So the TM of PETE is around 260 degrees Celsius, which is important when you compare it to the other things of the experiment.
So we're going to be showing the heat transfer from a flame from this candle to an empty water bottle, and also a water bottle filled with water. So obviously the boiling point of water is 100 degrees Celsius. So we're going to show that when this is exposed to the flame, that water, instead of letting the PET bottle melt like it will with the empty one, this is actually, the water is going to absorb that energy in order to boil. And so it's not going to go to the plastic, and the plastic's actually not going to melt.
So yeah, like you said, once the water reaches 100 degrees Celsius, it hits a plateau, which means it can't get any higher in regards to temperature in the liquid state itself. So what it does is the water will stay at like 100 degrees Celsius until it turns into gas, which is water vapor. So that's like when you're boiling water for pasta, that's like the vapor is coming off. So that's what happens when it gets above the 100 degrees Celsius. And then a flame burns at these temperatures here. So obviously these temperatures are significantly greater than like the melting point for PETE, which is 260-ish, and then the temperature to boil water, which is 100 degrees Celsius. So yeah, like Zach said, when you put the empty bottle above the flame, there's going to be heat transfer, so the plastic is going to absorb the energy, so it's endothermic. And the only resistance to the heat transfer is through the bottle itself. Whereas, like he also said, when there's water, there's resistance of both the plastic and the water. And since the water can't get above 100 degrees Celsius, it's not going to allow the plastic to get 260, which is where it's going to actually melt. So yeah, so we can see it briefly, I guess. So when you put it above it, it's gonna hit its melting point. So when the plastic hits its melting point, it turns from a solid to a liquid. And this is because the polymer chains, which is kind of how it's made up, are gonna become more mobile. So they're gonna be able to move and turn into a liquid. So they become like less rigid.
It's just like ice melting, same type of thing. So you see, with the water inside,
it doesn't really melt. It doesn't melt because of the resistance of the water. So the water, like we said, can't get above 100, or else it will start boiling and evaporating and turning to vapor. So for this bottle to fully melt, you're going to need all of the water inside to evaporate, and then there will only be one resistance, which is it will just become like an empty bottle, so then it will be able to melt. So you can see clear difference. This one started to melt, that one didn't really. So
and the charring is just from the smoke from the flame.
So yeah, that's the basic description of this type of heat transfer, so how it works and the resistances of the bottle and the